So in this first lecture, I'll be talking about binomial distribution, which is one of the 4 types of distributions that are in your syllabus, right? So see, first of all, what is binomial distribution? In case of binomial distribution, there can be only 2 types of outputs. That is, there can be only 2 types of results. Out of this, we call one result as success and we call one result as failure. What can be the examples of binomial distribution? See, binomial distribution can be any distribution in which there are only 2 outputs. For example, what can be, first example can be our toss of a coin. See, whenever we toss a coin, there can be only 2 outputs. It will be either heads or it will be tails. Now, in case of toss of a coin, both the probabilities are equal, right? Heads is 50%, tails is also 50%. So we can write 50% as what? We can write 50% as 0.5. We can write 50% as 0.5, right? So the probability of heads is 0.5, probability of tails is 0.5. Similarly, what can be another example? Another example can be something like result of a match, right? Result of a cricket match, let us say. See, I know in cricket matches there can be other results such as draw, tie, there can be match washed out because of rain. But let us say that we are considering a perfect match. Okay, so in a cricket match, what can happen? Either the team A will win or the team B will win, right? So it is not compulsory that the probability of both of them winning is 0.5, right? It is not compulsory that it is 50%. For example, let us say that team A is Australia and team B is Bangladesh, right? So in this case, what is going to happen? In this case, the probability of Australia winning is more. The probability of Bangladesh winning is less. So we can write what? We can write that the probability of Australia winning is something like 0.8 and probability of Bangladesh winning is 0.2. So if we are supporting Australia, then this will be our chances of success. But if we are supporting Bangladesh, then our chances of success will be 0.2. So it depends on us what are the chances of success. For example, we can take another third example of binomial distribution which is related to mechanical engineering. For example, suppose you are manufacturing a part in a company, right? So whenever you manufacture a part in the company, let us say on the lathe machine, after you manufacture the part, either the part is going to be accepted or the part is going to be rejected, right? If it is within all the required dimensions, if you have manufactured it properly, then the part is going to be accepted. But if you haven't manufactured it properly, then the part is going to be rejected. It is possible that the possibility of acceptance might be 95%, right? And possibility of rejection will be only 5%. So in this case, what is going to be our success? It is possible that accepted might be our success. So in this case, this will be what? 0.95. And what will be the probability? 0.05. Right? 5% means 5 divided by 100. So 0.05. So any distribution in which there are only 2 results, that can be thought of as a binomial distribution, right? So these were some examples of binomial distribution. So whenever we are solving a binomial distribution, what are the variables that we have to keep in mind? See, whenever we are talking about binomial distribution, we are interested in 3 things. What are those 3 things? First is n, second is p, and third is q. What is n? N is the total number of experiments, total number of experiments, or we can say total sample space. Okay, I will explain all this in just a few minutes, but just note these points down. That n stands for what? N stands for total number of experiments or the total sample space. What is p? P is the probability of success. Okay, probability of success. And what is q? Q is the probability of failure, right? Always remember, in case of binomial distribution, there is only going to be success or failure, only 2 outputs. Now, And we know the addition of all probabilities is what? Addition of all probabilities is always 1. So we have to remember that P plus Q is going to be 1. Addition of all the probabilities is always 1. So P plus Q is equal to 1. Right? So to understand this, let us say, okay, let us take the Australia Bangladesh example. Let us say that there is some kind of a betting place where you are doing betting, and it says that the chances of Australia winning is 0.9 and the chances of Bangladesh winning is 0.1. Right? Now what is going to be n is going to be the total number of experiments. Means what? N is going to be the total number of matches that are going to be played between Australia and Bangladesh. Let us say that it is a 7 match series, right? So in case of a 7 match series, 7 is going to be our sample space. 0, if we are supporting Australia, then probability of success is 0.9, probability of failure is 0.1. Similarly, in case of our engineering example, let us say that randomly we select 50 sample pieces. Okay, we selected 50 sample pieces, and we know from previous example that our defective percentage rate is 10%. Okay, 10% parts are defective. So in this case, what is going to happen? Our n is going to be 50. Our probability of success, let us say in this case, probability of success is a good part. Okay, so P is what? Good part, which is accepted. It is going to be what? 90%, because 10% are defective. Na? 90 means what? 0.9. What is the probability of failure? Failure means what? Bad part, which has to be rejected, defective. It is going to be what? 10%. So it will be 0.1. Right? So n is what? N is our sample space. Probability of success is 0.9. Probability of failure is 0.1. Right? So these are the three things that you have to remember always. Right? So let us solve a few sums based on this. Let us take one example. Let's just say I will write over here. What can be the example? I will take one example from our question bank only. Right? So let us open. Okay, so let us say this is our question bank. Okay, let us look at question number 5. Question number 5 is of binomial distribution. So what are they saying? They are saying 5 defective parts got mixed up with 15 non-defective parts. Right? So what is the defective parts? There are 5 defective parts, and what are the non-defective parts? There are 15 non-defective parts. So we can write over here defective parts is equal to 5. Non-defective parts is equal to 15. If there are 5 defective and 15 non-defective, then what is going to be the total? Total is going to be 5 plus 15. So what is the total number of parts? Total number of parts is 20. What is the next thing that they have told us? If 4 parts are selected at random. So how many parts are we selecting? We are selecting only 4 parts. So 4 is going to be what? 4 is going to be our sample space. N is equal to 4. This is what? This is our sample space. If 4 pieces are selected at random from this sample, find the probability that at most one of them is defective. What are they saying? That at most one is defective. Means there can be 0 defective parts or there can be 1 defective part. Right? At most one means what? 0 defective is also allowed and 1 defective is also allowed. Right? So how do we find out the probability of 0 defective parts? To find out the probability of 0 defective parts, we will have to use the binomial formula. What is the binomial formula? Binomial formula says if you want 0 defective parts. So in this case, we are interested in what? We are interested in defective parts. So our success is going to be what? What is going to be our success? Our success is going to be a defective part. Right? We are interested in defective parts now. So our success is going to be a defective part. What is the probability of getting a defective part? Total defective parts is what? 5. What is the total number of parts that we have? 20. So what is the probability of getting a defective part? 5 upon 20, which is what? 0.25. What is the probability of failure? Failure means what? Non-defective part. Failure means non-defective part. How many non-defective parts are there? 15 non-defective parts. Total number of parts is 20. So Q is going to be 0.75. Right? So we know the value of P, we know the value of Q, and what is our sample space? See, there are total 20 parts. But out of those 20 parts, are we checking all the 20 parts? We are not checking all the 20 parts. We are checking only 4 parts. So our sample space is 4. So n is equal to 4. So what is the probability of getting 0 defective parts? See, in case of binomial theorem, the formula is like this. P of x is equal to whatever the value that you are interested in, let us say small x. We can say it is given by ncx p raised to x q raised to n minus x. This is the formula, right? C stands for combination, permutation, combination wala combination, right? So we are interested in what? Probability of x is equal to 0. So it means what? There should be 0 defective parts, right? So what is our sample space? 4, n is equal to 4. So we write 4c0. What is the probability of getting a defective part? 0.25. So 0.25 raised to 0 into 0.75 raised to 4 minus 0, which is going to be 4. So you can substitute all these values and you will get the answer. So if we substitute all these values, the value that we are getting is 4c0, which is going to be 1 into 0.75 raised to 4. It comes out to be 0.316. So the probability of getting 0 defective parts is what? 0.316. Now similarly, what is the probability of getting one defective part? The probability of getting one defective part will be 4c1 into 0.25 raised to 1 into 0.75 raised to 4 minus 1. 4 minus 1 is what? 4 minus 1 is 3. So again we can put these values in the calculator, which is going to be 4 into 0.25 into 0.75 raised to 3, and it comes out to be 0.422. 422. So they said what? They want the probability of at most one defective part. ज्यादा से ज्यादा एक डिफेक्टिव पार्ट, मतलब 0 डिफेक्टिव पार्ट भी चलेगा, एक डिफेक्टिव पार्ट भी चलेगा. So probability of at most one defective is equal to probability of 0 defective plus probability of 1 defective. So that is going to be 0.316 plus 0.422, which is going to be 0.738. So this is the probability of at most one defective part, right? So this was the first sum of binomial theorem. So I will move on to the next sum in the next video. Thank you.